Alright, so now that we have our workflow laid out, we can try to implement these functions. So I went ahead and created two more modules that we're going to need: a storage module to store our token ID and a callbacks module for the callback that we need. Let's try to implement the issue token function. So first of all, the issue contract call costs 0.05 EGLD. So that means we're going to need to have a payable endpoint. Alright. And there are two ways of writing this transaction. The easiest way is to just use our send interface and then search for ESDT system smart contract proxy, which is basically a quicker way to create transactions. If you go deeper with Rust Analyzer into ESDT system smart contract proxy, it just creates an ESDT system smart contract transaction, which is basically a new transaction, but the address and the proxy is already set for you. Once we do that, we just choose from all these functions, and we need to issue a non-fungible token. And then, because it's an async transaction, we will end it with async call and exit. Alright. So there's a few parameters that we're interested in. Let's add them here. Token display name. This is going to be a managed buffer. Token picker. And let's use some default properties for now. Okay, the issue cost should be equal to the EGLD that we send to this transaction. So we're going to take the EGLD value from the call value. Alright. Let's also clone the value so we have a big win. And the properties, as you can see, they are of type non-fungible token properties, and we can just pass the default for now. So this would be our issue token ID transaction. Wait, we have to also add the endpoint as well, so we can actually call this function. Alright, so from what we talked before, when we do this transaction, it's an async call to the ESDT system smart contract, and because it's an async call, the only way to retrieve the result is through a callback. So we are going to need to define a callback and add it to our transaction, and we go to our callbacks module, and we can define a callback. This callback takes an argument specified with call result, and it's going to be of type managed async call result for token identifier, so we know we're going to receive a token identifier. Then we do a match on result, and if it's okay token ID, then we're going to remember our token ID in the storage. So let's say we have storage called last issued token ID set token ID. Otherwise, we're going to free up that storage. So we always know when we have this storage, that means when we have value in the storage, that means that transaction was successful, and when we don't, that means that the last transaction was unsuccessful. And we're just going to use one storage for every type of token. Alright, so there's a few errors here. I think it's because not imported anything that we need. Okay, that solves a part of them. Okay, so it cannot be just okay, it has to be managed async result. Alright. Cool. We cannot see the storage because the module is not imported. So we have to import it here as well. And still we cannot see the storage because we have not defined it. Yeah. So let's define storage. Last issue token ID, which is going to be a single value mapper. We only need to remember one value of type token identifier. And I think we also need to import stuff. Yeah. It's always a good measure to just import it and see if you use it and then delete it afterwards if you don't use it. Okay, so this is our callback. Now we have to attach the callback to our transaction, so we're going to do that using callback. So callbacks and issue token callback. As you can see, we have an interface in itself which returns all the callbacks marked by this annotation. Alright, so that would be our issue function. We need to also create an endpoint to add rows, and we're just going to pass the rows as parameters. ESDT local row, that's a framework type, and this is a no-cost transaction. But as usual, you can use the send interface to write everything easier. Through the ESDT system, smart contract proxy, you can find the set special rows function. Also an async call. Alright. So first parameter, the address for so where do we need the rows to be? The token identifier. For what collection, and the actual rows. So the address would be the own contract address. Get smart contract address. The token identifier will be the value that we have in storage, our last issued token ID, and the rows we just need to iterate through them. As you can see, it's an iterator, so let's just run it. Okay, so this is our add rows function. Now let's try to also write the mint function, which is the add quantity function for the NFTs. Okay, same as before, we just copy this and we try to find a mint function for us. Right. As you can see, it only asks for the token identifier and amount. We can pass amount as a parameter as well. And then we can find the token identifier from the last issued. Okay. These are the 3 steps that we need to implement to actually create an NFT collection, add some rows to it, to the contract actually, so that the contract can do modifications, and then mint an NFT from that collection.